All right, chemistry students. This is Mr. Thomas. Um, we're going to hopefully do a little bit of review here to get the year started. Um, this is going to follow along with the PowerPoint presentation that I have on Canvas that you can find under modules. Okay, so let's begin. Again, hopefully, this is a little bit of review. If not, that's okay. So let's start off by explaining what chemistry is. And here we have Walter White from one of my favorite TV shows, Breaking Bad. If you haven't seen it, I highly suggest it. He says that chemistry is, well, technically, chemistry is the study of matter, but I prefer to see it as the study of change. And if you have seen the series, you know that's a bit of foreshadowing, as Walter White himself changes quite a bit. But in this class, what we're going to study is how matter changes into different things. Okay, so it's important to keep that in mind. But what is matter? Matter is anything that has mass or takes up space. So, mass, anything that you can measure on a scale or takes up space, meaning volume. Okay, so pretty much everything constitutes matter. So, chemistry is the study of just about everything and how everything changes. Okay, here's a diagram that splits up matter into its different parts. This is something that I suggest you pause the video on and maybe write it down or take a picture of it somehow. But let's go over this really quickly. So matter, what we have here to begin with, is everything. You can break that down into two logical pieces: pure substances and mixtures, right? Because there's really only those two things. Pure substances can further be broken down into compounds, such as water, which has the chemical formula H2O, and elements, okay, like carbon, iron, nickel, things like that we can find on the periodic table. On the other side, mixtures over here, mixtures can be broken down into homogeneous, things like alcohol or Gatorade or Kool-Aid, anything that has a consistency throughout it. And then opposing that, let's put verses here, we have heterogeneous. So that would be things that are not consistent throughout, things like soil, because it has little particles of rocks and sand and mud or dirt, and wood, right? Maybe this wood has knots in it and it has grain, okay? And then down here, elements can be broken down into three different categories. We have metals, things like iron. We have nonmetals, things like oxygen. And metalloids, things like silicon. All right, and we're going to get much more into detail about all of these later, but I first wanted to give you a general background into how matter is broken up and categorized. All right. So, define the following. In class, what the students are doing here is they're going to define these. You can go ahead and make your own definitions, or we can just talk about what they are. Okay, so I have some definitions here already laid out for you. So let's talk about element. Elements are substances whose atoms all have the same number of protons, okay? So protons are what tell you what the substance is, okay? And we'll get into more of what protons are. but we first need a definition of what elements are. A compound, okay, is a substance formed when two or more elements are chemically bonded together. So, for example, let's go back to water. H2O would be the combination of hydrogen and oxygen, right? And you would have two of these, two hydrogens for every oxygen. So that's what a compound would be. Another compound would be like glucose, C6H12O6. All right, if you've taken biology, you know all about this molecule right here. All right, moving on. Homogeneous mixture. A homogeneous mixture would be a solid, liquid, or a gas that has the same proportions of its components throughout any given sample. So, like I said earlier, something like if you were to have a glass of your favorite drink, let's say that it's Kool-Aid, okay, the whole thing would be consistent. No part of it is chunky, no part of it's different, it's homogeneous, okay? The root word here, homo, means same, like Homo sapien. All right, solute would be the substance dissolved in solution. So in our Kool-Aid mixture, what would be the solute? The solute would be the Kool-Aid powder. And going along with that, the solvent is the liquid in which the solute is dissolved. That would be the water. Okay, so let's say water here and powder. Another word for a homogeneous mixture would be a solution. Okay, I like to tell this joke to my students. It always gets a good reaction. And it goes, in chemistry, alcohol is a solution. All right, so hopefully I don't get in trouble for that. An alloy also belongs under a homogeneous mixture because it's a metal made by combining two or more metallic elements. So an alloy could be something like a wedding ring. All right, wedding rings are rarely pure metals. They're rarely pure gold or platinum or whatever for a few reasons. Because gold is very expensive, platinum is very expensive. Gold is very malleable as well, which means that it can be deformed. So an alloy would be mixing other metallic elements into the gold mixture, diluting it, and giving it new characteristics, new properties that are more desirable. So a wedding ring, for example, would be much stronger if you combined it with other metals. Okay. And then lastly, we have heterogeneous mixture. And that is any mixture that is not uniform in composition. So, like we just said on the previous page, wood or soil or chocolate chip cookies or pepperoni pizza, things like that are not uniform in composition, so they would be a heterogeneous mixture. All right, got those definitions out of the way. Let's talk about properties of matter now. So, a chemical property is a characteristic of a substance that is observed when it undergoes a chemical reaction. Examples would be toxicity, flammability, chemical reactivity, etc. All right. And chemical reactions involve the redistribution of atoms, like rust, digestion, combustion, right? So, rust, for example, down here, instead of having just iron, you can make iron oxide, which is rust. Okay, so when it combines with oxygen in the air, it forms something completely different. Likewise, combustion reactions, you have something and it combines with oxygen in the air and it forms something different. Likewise, digestion through enzymes in your digestive tract. All right. So many of you have probably learned this before in middle school, but I figured it was just a good idea to review this. Okay. And opposing those two, we have physical properties. So physical properties are characteristics that are observed without changing. Okay. This is the key word right here. Without changing the chemical identity of the substance. These are things that you can see. Texture, color, melting point, density, those are all things that you can measure and observe without changing anything about the substance. And physical reactions only involve a change in appearance. For example, melting, freezing, or evaporating water. All right, so water can undergo many physical changes, right? So that's pretty simple. And lastly, I just wanted to mention this, the water cycle, okay? The water cycle is a good example of endothermic and exothermic reactions, okay? Endothermic reactions, as the name implies, endo means into, and thermic relates to heat. So an endothermic reaction, the heat would be going into the substance. Whereas exothermic reactions, the opposite is true. Heat is leaving. So let's draw this really quickly. So into, delta H is the universal symbol for heat. Going into something would be endothermic, and exothermic would be the opposite. So delta H, heat, is leaving the substance. All right, and here are some phase changes that we're going to be talking about this year. This is just a good picture to reference if you're ever confused about what these are. Some of these we know very easily. So a liquid going into a solid would be freezing. The opposite of that would be melting. A liquid to a gas would be vaporization. And the opposite of that would be condensation. And a solid to a gas would be sublimation, maybe a new word for you. And a gas to a solid would be deposition. Okay. Go through this little diagram here and try to make sense of why deposition, condensation, and freezing would be exothermic reactions, meaning heat leaves, and why sublimation, vaporization, and melting would all be endothermic reactions, meaning heat goes into those reactions. All right, that's all I have for this slideshow. I'll catch you on the next one.